Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled A Handover Decision Model for Unmanned Vehicles for Ubiquitous Communication in Wireless Networks. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Welcome to TechPacks Research and Innovation Services. Today I'm here to present you one of the recent research work that we have done in the domain of the unmanned aerial vehicle, in which the handover scheme has been proposed for the multi-level decisioning model. So before moving to the video, let's talk about that what we will cover into this video. In this video, we will initially talk about the application areas under which the design protocol can be embedded and advantages of it can be implemented to the industrial versions. Then whatever the code we have designed, how to execute it, which files you have to run, and what are the software and the library requirements for that. Further to that, we will discuss about what are the current systems, those are working in the same domain, and what exactly they have implemented and the problems identified in them, followed by the proposed methodology that we have implemented and how it is handling the problems. Lastly, we will talk about the experimental outcomes and the findings that came out from the simulation. So let's start with the application areas. The application areas of the handover schemes are in many of the domains, especially where the mobile communication is to be done. So in the daily life, like we are using the cell phones and also their mobile communication, the handover management scheme are very much successful. Other than that, the unmanned aerial vehicle, those are very much popular for this handover schemes, especially the drones based methodologies where unmanned aerial vehicles are used by the military applications. Even for the other application areas like civilian use or public use or the military use, the unmanned aerial vehicles can be used. So now the point is basically what exactly the handover is basically when the device or any of the equipment that is moving, either it is a mobile or the drones, when they are moving, they need to get connected with the internet so that they can transfer their surveillance data either by the camera or the cell phone like signals. They need to get connected to the network, and when we are moving, the network range is restricted, so they need to switch from one network to another. So basically we need, when the cells are changed, we need to here you can see this is the example that this is a location 1 BTS and another BTS. When a device is moving from A point to B point, they need to change their location, and the range of the location A tower and B tower is specific. So moving from one cell to another cell, we need to hand over the signal so that they get connected to the network through the another base station's network. So here the handoff actually works. So this is the applications like mobile communication, unmanned aerial vehicle. There specifically it is used specifically for the military, civil, and many other applications. Now talk about the code. So you can see there are the code that we are going to provide you is basically this folder, that code under which you can see there are a number of files with us. So in order to run this code, so what we are doing, we have implemented the whole thing in the MATLAB. So the MATLAB software must be with you. The MATLAB version that we are using is MATLAB 2019A. So in order to run that, you can see either you can implement it in MATLAB 2015 or the above, but make sure it should be the full version or the trial version. So to run the code, you just need to go to the folder and copy the path, and then go to the MATLAB and paste the whole path and press enter. When you will press enter, you can see the whole files will be there with you in order to run that. So we do have the different files with us. Here you can see one of the file is the first fuzzy, second is the second fuzzy, and then is the third fuzzy, and this is the main code that we are gonna run. So main code, so you just need to open this file. So these are the fuzzy systems, those are used to generated in the scenario of the proposed work, and finally in the main code where the all these three files has been used and the whole scenario has been implemented. So in order to run the code, you just need to select the file whatever you want to run, and it should be under the editor window. There there you can see a play button which is used to run a particular file in the MATLAB. So when you will click on this run button, you can see all the files will be generated and the files will be written in the current scenario. So when I'm going to run this, you can see everything will be processed, will be shown, and the resultant file can be seen. So these are the three files: fuzzy1, fuzzy2, fuzzy3. It is having the fuzzy systems that we have designed for the proposed methodology, and on that behalf we are using these decisionable models in the proposed methodology to take the handovers. So all these details has been given into this, and I will talk in the detail with it also. So in the meantime, before running the main code that what exactly it does, let's talk about the problem and the current system. Currently many of the systems has been proposed in the domain of the handover decision. So this was one of the paper that we were following, in which they have designed an intelligent handover scheme using the fuzzy interface system. So what they have done, they have implemented the whole methodology by implementing the fuzzy, under which they have taken two of the decision models, like decision values. One is the speed limit, another one is the coverage. So by getting these information of the device, they are taking the decision that how much whether they need to give the handover or not. So they are taking the decision on these two parameters, but it is not limited to these two parameters. There are certain other parameters under which the decision can be taken, and further stability of the connectivity of the device can be maintained. So handover must be limited, because whenever handover is given from one cell to another, it is quite difficult to get stable, and the loss of the data can be there. So we should get the higher delivery rate with the less delay. So the problem that identified is, like, firstly we need to extend the data. Now the second problem is, if we are going to extend the parameters, the fuzzy is restricted with the limit of the parameters, because as the parameters will increase, the complexity of the system will get also increased. So we need to design a system in which the multiple parameters can be implemented. Secondly, we can use the fuzzy system with them in order to reduce the complexity. So this is how we need to design the whole system. So what we did in the proposed methodology, we have considered multiple parameters. Those include coverage, speed limit, cost. In the second of the scenario, we are using connection time, security, and power consumption. So a total of 6 parameters are with us. So if I'm going to design one of the single fuzzy under which we do have the 6 parameters, so obviously the fuzzy will be more complex, because the combinations will be on the basis of the 6 parameters to take the probability for the handover or not. So what we have done in the proposed methodology, we split the parameters as per the category. So you can see, as per the category, the coverage, speed limit, and the cost, these are considered under one fuzzy, and the other parameters like time, security, and the power consumption, it is considered in the second fuzzy. So the parameters we will calculate from the system will be these 3, but set of 3 will be given to fuzzy 1, set of second will be given to fuzzy 2, and 2 of the probabilities will be taken from this. Now as we need to get only single probability, so these two fuzzy evaluations must be combined to get the final probability value. So in the third of the fuzzy system, we are getting the probability value from the fuzzy system 1 and fuzzy system 2, which gives us the estimation level. So this hierarchy is, like, you can say, I'm going to show you the block diagram. Here you can see we do have, sorry, we do have fuzzy 1, then fuzzy 2. Whatever the output will be there from a set of 3 parameters and set of 3 parameters, this probability will be given to the third fuzzy system, which is only taking the probability from the system 1 of 3 parameters, probability 2 of the rest of the 3 parameters, and these two probabilities are evaluated in order to get the final probability, which can be termed as PF. So on the basis of this probability value, we can decide that whether the handover is to be done or not. So this is basically the proposed scenario, where it is termed as multi parameters and multi-level fuzzy system, because this is fuzzy 1, fuzzy 2, and this is the fuzzy 3, which is combining. So this is multi-level fuzzy. So in the main system, we have called these 3 fuzzy systems which we have designed, created the scenario as per of the base paper, and then as per that, the data that we are sending, the location of the base station has been given, and 2 of the scenarios where the random movement of the nodes is there. So you can say the nodes movement is generated randomly, and then we have calculated all the parameters, that distance, coverage, and the cost, and given to fuzzy 1. Then connection time, then power consumption, and third parameter is given for the fuzzy 2. So two of the fuzzy outputs are given to the fuzzy 3, here you can see, and then get it the output in the terms of the estimation level for the further improvement. Then we calculated the delay, throughput, estimation level and all. Similarly, we have done it for the straight line communication, where it is moving to the straight line, not the random one, and all the parameters have been calculated. So when I'm running this code, you can see whatever the results we will get, that is compared with the base paper as well as a fuzzy system which is having all the networks in a single one. So here you can see we do have the results, those are under the category like results, where we have evaluated for random and state both. So estimation level, here fuzzy is the base paper result, proposed fuzzy is when we have used on the single fuzzy with all the parameters, and M fuzzy is the multi-level fuzzy that I just explained you, that what we have done in the proposed one. So in the evaluation purpose, you can see our proposed methodology is having the least estimation level, packet delivery ratio is higher, this is the packet delivery ratio percentage. The third parameter is like packet loss, which is also less in our scenario. Even the second scenario where the only parameters were increased, in that scenario also basic fuzzy systems, in comparison to the basic fuzzy system, our system was better, but the final proposed system with the multi-level and multi-parameter system is much effective. Similarly, for the case of the throughput, you can see in our system the highest throughput is being achieved, and for the delay it is also lesser in both the random and the state scenario. So further modifications are still possible, and the parameters and the dependencies of the handover can be evaluated in order to get the more stable network and the connectivity among the unmanned aerial vehicles. So for those details, the industrial or the research people can contact us directly and can get the details. Thank you.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.